Welcome to Easy to Learn Technical Skills. Today I like to explain about the concept of nonlinear data structure. Nonlinear data structure is opposite to linear data structure. In nonlinear data structure, the data values are not arranged in order and the data item is connected in several other data items. It is used to memory efficiently and free contiguous memory allocation is not required for allocating the data items. It includes tree and graphs. It is a form of data structure and don't stay arranged linearly or sequentially. Since the data structure is a non-linear, it does not involve any single level. There are multiple levels are there in the nonlinear data structures. So in this video I like to explain about the concept of tree. So in nonlinear data structure is a complex tree implementation, as well as I said multiple levels are there. So I like to explain about the concept of tree terminologies. Node, which means that item or information. So while we drawing a tree diagram, so in this tree diagram, whatever the value you are going to store, that is called as item, and we can refer the common term is called as a node. And the path, a path is in a given tree a list of distinct nodes in which successive nodes are connected by edges in the tree. So there is exactly one path from each node is to root node. That is called as a path between the node to the root node. Ancestor, node A is the ancestor of node B if A is the parent of node B. So all the things we are going to discuss in the form of diagrams. Length, the length is defined as the number of edges on the path. Level of node, level of root node of the tree is 0 and the level of any other node in the tree is 1 more than one level of the given node is from the parent. Descendant, node B is the descendant of node A if A is the ancestor of B. Root node, the first node from where the tree originates is called as the root node. So according to this diagram, so the root node is called as the first node. Whoever the node that comes at first, that belongs to the root node. So in this diagram, A is called as the root node. In any tree, there is must be only one root node. So in this diagram, we can't say that other nodes are called as root node. So the root node is called as a one and only node which comes at first and it's originating the tree, and that is called as a root node. We can never have multiple root node in the tree data structure. The next concept is called as edge. The connecting link between any two node is called as an edge. So according to this diagram, this is called as an edge. So A to B, the B will be connected with the help of A. So that is called as a, through the help of the edge, we are going to connect each and every node. So that is called as an edge. In a tree with n number of nodes, there are n minus 1 number of edges. According to this diagram, 8 nodes are there and exactly n minus 1 edges are there. So 7 edges are there. The next concept is called as a parent. The node which has a branch from it to any other node is called as a parent node. The node which has one or more children is called as a parent. According to this diagram, so A is called as a parent node and C is called as a parent node and G is called as a parent node and D is also called as a parent node and B also called as a parent node. A node which has a branch or any children node have, that is called as a parent node. The next concept is called as child node. The node which is a descendant of some node is called as a child node. All the node except the root node is called as child node. So from this diagram, C is called as a child node of A and E also called as child node. F also called as child node, H also called as child node, H also called as child node, and G also called as child node of D, D also called as child node of B, B also called as child node of A. So A is a root node. The originating node may have two children or one or more children, and the children may have further children. So the root, except the root node, all the nodes are called as child node. The next concept is called as sibling. The node which belongs to same parent is called as sibling. So for example, according to this diagram, here B and C are called as sibling and E and F are sibling. So which means that both are having the same parent of called as C and B and C having the parent is called as A. A node which belongs to the same parent is called as sibling. Degree. The degree of a node is the total number of children of a node. For example, A degree is called as a 2. Why? Because it has 2 children. Then B, it has only 1 children. So that is called as a D. Then D, we have only 1 children is called as G. And G having only 1 children is called as H. And C having 2 children, one is called as E and one is called as f, and this is the way we have to calculate the degree. So degree of a node is called as total number of children of a node is called as a degree. The next one is called as internal node. A node which has at least one children is called as internal node. Internal nodes are also called as non-terminal nodes. Every non-leaf node is called as internal nodes. According to this diagram, so C is called as the internal node, and B also called as internal node, C also called as internal node, and G also called as internal nodes. Next one is called as a leaf node. A node which does not have any children is called as a leaf node. A leaf node are also called as a terminal node. According to this diagram, H is called as a leaf node, and E is called as a leaf node, and F also called as leaf node. A node which does not have any other children is called as leaf node. Level. In a tree, each step from top to bottom is called as a level of a tree. The level count starts from 0, where it is incremented from 1 by 1. So here the level of the given tree initiated by the root node, the root node level is called starts with 0, and the next level incremented by 1 higher level than the root node is called as 1, and the next incremented by 1 level is called as the next level, and this is a third level, and this is a fourth level. So the level starts from 0, and it is initiated from the root node. The next concept is called as a height. The total number of edges that lies on the longest path from any leaf node to a particular node is called as height of the node. Height of the tree is height of the root node. According to this diagram, the height starts from the leaf node, and the next level it is incremented from one level higher than the leaf level, and this is the next level, and this is the next height, and this is the next height. So the height will be calculated from height. The total number of edges that lies on the longest path from any leaf node to a particular node is called as height of the node. Height of the tree is height of the root node. For example, according to this diagram, the H height is called as a 0. So here the H height is called as a 0, and G height is called as 1, and D height is called as a 2, and E height is called as 0, and F height is called as 0, and C height is called as 1, and B height is called as a 3, and A height is called as a 4. So which means that the longest path from any leaf node to a particular node is called as height of the node. Depth. Total number of edges from root node to a particular node is called as the depth of the node. The depth of the root node is 0. So here the depth starts from the root node, and the root node depth is called as a 0, and the next level depth is called as 1, and next level depth is 2 according to this diagram, and the next level is 3, and final depth of the given tree is called as a 4. The next concept is called as a subtree. In a tree, each child forms a subtree recursively. Every child node forms a subtree on its parent node. So in this diagram, this is called as a subtree, and this is called as a subtree, and this is also called as a subtree, and this is called as a subtree. A tree, each child forms a subtree recursively. Every child node forms a subtree on its parent node. The node may have children on its parent, it forms a subtree. So according to this diagram, see here, this tree is called as one parent node and as well as one child node. It will forms one subtree. So likewise, the tree may have multiple subtrees. The next concept is called as a forest. So forest, a forest is a set of disjointed trees. For example, I like to divide the given tree into two subtrees, and A, while we removing the A, we may get two different subtrees. So likewise, the disjoint tree is called as a forest. Thank you for watching my channel. Thank you. In the forthcoming videos, I like to explain about the concept of tree traversals. Thank you.